A few comments on alternatives to petroleum for transportation. How do we kick the gasoline and diesel fuel habit if we want to keep our global climate somewhat stabilized? So, wow, that's a tough question. And that is what I want to talk about now a little bit. If we were to use natural gas to power our vehicles, which is technologically feasible and fairly reasonably low cost per mile, the one problem is that we don't have a retail infrastructure. Where would you fill up with natural gas? It's a whole different kind of thing. You wouldn't probably haul it in big trucks from station to station, but rather in pipelines. So you'd have to have a big infrastructure. But anyway, even if we could do that, and we could, there's a couple of problems. One is the price of natural gas is very unstable, and if we banked our national future on getting around on natural gas rather than gasoline and diesel, we could end up with a very expensive natural gas price, as we're not really sure how long our supply will be plentiful, and that would be a very backfired strategy. So the other problem, of course, is that natural gas is a greenhouse gas. So we really haven't solved the problem. Maybe we would cut our emissions a bit. So not a good alternative, really, if we're wanting to stabilize the climate. What about hydrogen? Can we go out and get hydrogen? No. Hydrogen has to be made. There are a lot of ways to do it. You can hive off hydrogen molecules off of fossil fuels is one way, but then again, you're still fossil fuel reliant. Another way is to use clean electricity, like from solar and wind, and you would go and split the water molecule. And you would have those hydrogens. It takes a lot of energy to do that, and then you would store those hydrogens and then use them when you wanted to combining them with oxygen again, and then there's that huge energy release when that happens, and that is electricity. And in fact, fuel cells are what do that, and they've been around a long time. The problem is it's still really expensive. We do have operating hydrogen automobiles. There's some in California. There's a little area in Southern California where they have hydrogen highway. The Japanese energy planners are very interested in this, but they don't have any breakthroughs. It's really, really expensive to do still. And I've been hearing that for 25 years. It might be the most elegant solution, maybe even more so than, say, what we're doing now with auto batteries, the whole EV kind of thing. But it's a chicken and egg problem too. You got to build a huge hydrogen infrastructure to get the stuff around. But do you do that before you get the cars or after you get the cars? But nobody's going to buy a car if there's not an infrastructure. You got a chicken and egg problem. So you'd have to have a huge expenditure by the government to make an infrastructure to make it work. And we still don't know if we can really do it cheaply enough to even begin to compete price wise with gasoline and diesel. So hydrogen is still a way out there kind of proposition. I wouldn't count it out, but I wouldn't see it anytime soon either in major amounts. I don't think we will. Biofuels, next alternative. What's the story with those? So, oops, I lost my screen there. Let me try that again. Biofuels are, I gotta figure out how to use this better. There we go. Biofuels have some disadvantages or drawbacks. They have a very low power density, photosynthesis does, and they thus require a large area of farmland. So if you're going to grow, for example, corn ethanol and run your whole fleet on that, that's a problem. Number two, we're already claiming a large part of our biosphere's permanent productivity for other things, especially food, and we would lose even more biodiversity and degrade our lands even more if we went that way with biofuels to power everything. In addition to that, number three, the economic and energy costs are high. Okay, it's not cheap to do that, and you have to put a lot of energy into those fuel systems in the first place to fertilize the crops, machine irrigation, all of that. So it's not cost effective typically. Much of the U.S. ethanol industry gets some kind of government subsidy, and yes, it is 10% of our fuel supply, though. And so the example of U.S. corn in number three there, ethanol is 10% of our gasoline, but occupies 40% of our corn land. If you just kind of project that math out, you run into some real problems, don't you? What if you wanted to make this 100%? It would occupy 400% of our U.S. corn land, not an option, of course. So what if you took a acre of corn ethanol and used it as fuel versus an acre of solar panels? Which one would power a automobile farther? And we're going to look at that a little later. You might be surprised at the answer. Number 4, most land that could be used to grow biofuel crops is already used to grow food. So rising food prices are a potential consequence. So let's look a little bit at electric batteries themselves. The first is the cost of batteries. It's been plummeting, falling by roughly 15% a year. We are in the zone now, very, very close, probably there in some models where the cost of an electric automobile with that 200-mile plus range is about the same, similarly equipped, as it is for a gasoline-powered automobile. The energy cost per mile is an interesting one. And I would just say that the energy cost per mile is cheaper with electricity in almost any case. Here in Oregon, I just looked at the price I have in my own hookup for electricity in my home, and it works out to about 2 cents a mile to drive, say, for example, a Tesla Model 3 electric vehicle, and that would equate to roughly 60 or 70 cent gasoline, just to give you an idea. And that will never happen. So the energy cost per mile is already cheaper if you just look at energy itself. But the cars have been, until very, very recently, more expensive. And most of them still are, although they're kind of premium cars and premium performance. So they're not always talking apples and apples. But still, the price of batteries is still falling. That's exciting. And we're almost to break even, or already cost of ownership to a break even point with basic automobiles. The maintenance cost of electric automobiles is lower. Tesla's has some recent testing suggesting a 400,000 or 500,000 mile before replacing your batteries kind of duration. That's amazing. And then those batteries, by the way, would be put into arrays to store electricity in the grid when we have peak electricity times, and then release it when we need more. So that's a possibility for down the road. Can EVs disrupt global oil markets? And so there is a video I would like you to look on that subject in a minute. And I'm going to skip now down. I got to find this in our class here. I want to show you a real quick little questionnaire. It's kind of fun. It is corn ethanol or solar panels. In comparing how far one could drive a car utilizing either the annual production of 1 acre of corn ethanol or the annual production of electricity from 1 acre of solar panels with an otherwise similar electric car, choose the best response. You could drive about the same distance with either, or 10 times as far on the corn ethanol, or 100 times as farther on the corn ethanol, or D, you could drive maybe 10 times farther on electricity, or 100 times farther on electricity, D or E. Which is it? Wow, yes, the answer is E. How could this be true? Now, I posted this from my upper division class on this topic. And some of you don't have enough background to totally get into all of this, but just in a kind of quick nutshell, a lot of it is because photosynthesis isn't very cost effective. Maybe the best 1%, somewhere like this. But now we're getting the conversion ratio of solar to electrical energy of, say, 20%. So that already gives you a 20-fold advantage. But then you add in a whole bunch of other things as well, and you get something on the order of, it could be 200 or 300 times as far that you could drive on an electric car if you kind of follow all this through. It's kind of an amazing story. Electricity is the future, and we can do it pretty cleanly. Yeah, there is some waste when we make solar panels, we make wind farms, true, and yes, cars still are manufactured. There is energy involved there, materials. So there's no perfect system, but we don't have the need for a big global uh, release of greenhouse gases to do this. Why is that? Because electricity can be made pretty much 100% carbon free if we're using solar, wind, hydro. Okay. Now, here's the thing. Much of the grid in much of the country, though, isn't 100% renewable yet. It's still using fossil fuels. So only degree to which your electric car is running on a low fossil fuel but high solar-based energy, either solar or wind or hydro, only the degree to which it's running on clean energy in the first place, that source of electricity, is your electric car not emitting on a systems basis much carbon dioxide. In the Northwest here, we do have a pretty good system that way, in the order of 70% or so hydro and some increasingly wind. Not a lot of solar yet, but some good potential in some parts of the interior of the region. But here's the fun thing. If you have an electric car, through time, in most of the United States, the trend has been that your electricity gets cleaner through time. So the net system or embodied emissions of your electric car also have improved carbon dioxide emission over time, less and less and less. So the grid cleans up, the electric car system cleans up too, to a large degree. Okay, so kind of exciting there. And the nice thing is we don't really need much new infrastructure. A national grid would help a lot. Mostly what we have is interconnected regional grids, but we definitely have the basis for widespread use of electric cars. The price is getting there. The question is, are people going to buy them or not? And that is a question I simply don't have a good answer for. I see the Chevrolet Bolt now, B-O-L-T. It's priced very competitively, even cheaper than the Tesla Model 3. It's a nice, functional, fairly compact size hatchback car system, kind of a mini SUV sort of. And it's been kind of a dud. The Model 3 of Tesla's is much more popular. It's more money too, but they don't really have any better range. So it's not really a batteries problem here or a cost problem. People simply need to think about how to clean up their carbon footprint. And until the auto industry really gets behind this, it won't happen. The car dealers hate electric cars, most of them. Why? Because their main business model now is maintenance, not sales. With the internet, everybody knows what a car is worth. And there's not much markup in automobiles anymore, at least not like there used to be. So the way the auto industry makes money is through not sales of new vehicles, but maintenance. And the electric vehicle has 20, 22, 25, depending on how you count it, moving parts. Doesn't need a lot of maintenance. Tires once in a while, but really very, very little in the way of maintenance there. So the dealers have tended to shun them. That's one problem. I think some of it's just awareness too. People don't really realize what a wonderful performing vehicle a electric car can be, and how it does make a difference in our global carbon emissions. Probably not that many people really care that much, but Americans are starting to get the hang of this. And while we're slowly adopting electric cars in Europe, the sales are booming. In Oslo, Norway, over half of all the new automobile sales are electric. We're getting that kind of 5 to 6% of new sales are electric now in a lot of the European countries. So it is happening. China is the world leader in sales and in production of electric cars. And so, the world is changing. Will it change as fast as that video that we have here suggests to make it disruptive anytime soon? I have no predictions, especially now with the whole pandemic. It's hard to say what's going to happen. Anyway, hope you find this interesting and useful.